Okay, hello everyone. So today our topic is about current in a simple circuit. Okay, so let's move into the first part is about a circuit. So here, when you first learning about circuit, I think it's very hard for you to understand because circuit is very not very normal in our daily life. Maybe you're just charging your iPhone, like you're putting a battery in your remote control. Maybe right here you are thinking about circuit. Okay, so what is a circuit? There's an example in the real figures, okay? So here we first put a battery right here, and then we connect it with a wire and then connect it with a lamp, and then back to a switch, and then to the battery, okay? So for this, I gives you this example for the circuit, okay? So for the circuit, you can find maybe here the battery is just for a source or a supply for the electricity, right? So it's a source of electricity. And then a lamp is a kind of to use electricity, right? So it's just like a usage or use items or use substance or you can say that a substance which are used. Maybe substance is not very correct. Maybe for components, okay, I use components, okay, components which use the electricity, okay. And here is a switch. So switch is just to maybe we turn on the light, we close the light, right? That means a control for the electricity, right? So this is for how circuit means in the graph, okay? This is a very basic understanding of circuit. So maybe for many times you can just regard the battery as a source, or if it's just like a pump to like plug in and to pump some water, so you can just regard the current as a water current, okay, moves forward. And here is for the positive charge, okay? There's for positive charge and moving forward. So we can just regard it here to move the negative charge to negative terminal and to move them to positive terminal, okay, like a pump, okay, like a water pump to pump the water up. And then because of here is a height difference from the positive, maybe here is 10 meter, like you can regard it on the battery's left or positive terminal is 10 meter, and here on the right of the battery is maybe 0 meter, okay? So here the water will just moving from the highest places to the lowest places, okay? Like this way, right? And then move backwards to the negative terminal and then using the water pump to pump to the higher places, right? So it's just like this to make a make a loop, okay? And maybe for the lamp, because it used up the electricity, so it's like here's 10 meter and here is moving downward for 0 meter because it has blocked the like blocks this current and just use up the water, okay? Like this way. So maybe for here, we just have a conception of current, right? Current just from the high water level to the low water, okay? So it's from here, from the high places to the low places. So it's like just moving in this way, okay? So by considering about what is the circuit, and I guess you have considered about what is current. And for the most of the time, the scientists just regarded the currents just from positive terminal and because a positive charge and then moving here and to the negative terminal, okay? But we have said before that only the electrons can move, right? Because scientists find there is wrong. So, but we are very used to use the positive terminal to represent for the current source, okay? But in fact, it is negative charge from here, okay? So because positive charge cannot move, we have regarded positive charge as like moving in this way, but in fact, negative charge moving in a very opposite direction, okay? So we have a direction for current direction and another direction for the charge or electrons direction, like moving in this way, okay? This is what we think about the conception of the current, okay? So here is for the first part, we had to discuss what is a circuit and what is a current, okay? So here, how to draw a circuit is also very important in our task. Okay, in P4, you have to draw a graph. Maybe sometimes in P6, you're also trying to draw a graph on your task. Okay, so here, there are very some symbols right here. You can find there. The first symbol is like a single cell. So a single cell represents you are using a very long line and a short line to represent for this. And a long line means here is a positive terminal, positive terminal. And a short line means this is a negative terminal, like this way. Okay. So for positive terminal, it just gives out the charge. Okay, gives out the positive charge. But remember that for the real daily life, it's the negative electrons moving through the circuit, okay? So for this is a single cell, okay? And the switch we just using like two lines, and here is another like upper lines like to run for switch. So if you are closing the switch down, it's just moving the line just to make the total wire to connect it together. Okay, if you just want to block the current, you're just moving the switch up like this way. Okay, this is for switch. And for lamp, we can using like a circle and with a cross inside of this. Okay, this is for lamp. And here, the connecting wire, we're just using a wire or a line to represent for this, okay? And another symbol is called ammeter, okay? And also I have to introduce you another symbol is called voltmeter, okay? Okay, ammeter is just like apparatus to measuring the speed of the current. Like I have went to Germany before, and at that time I just watching. I was introduced to a very normal forest, and I knew that there's many jobs in the German, and the job is to take care of the forest, to take care of the nature resources, take care of the nature environment. Okay, and nature protector tells me that every day their work is to measure the like the environment conditions, or use an Excel number to represent for whether the condition is very good or bad. Okay, so they're using apparatus to measure whether in the stream the like moving very fast or moving very slow. Okay, because they can adjust, so they can judge whether it's in a good condition that the animals can drink water here and to live here and to have a very friendly environment. Okay, and to determine whether the water is polluted or not. Okay. So ammeter is just like we are putting in the center of the circuit like in this way, and from the positive terminal, here the current moves from positive terminal to this part up. Here also to illustrate that, in fact, it's negative charge, right? Okay. In fact, the negative charge to move, but we just regard it this is as a current direction, okay? Just a symbol of this, okay? Doesn't have another effect of our like determine the amplitude or determine the value of the current, okay? So if the positive charge just moving here and walks through the amper or ammeter, and you can find maybe here in 1 second that there's move 4 positive charges. Okay, so we can set their speed of the current is 4 charge per second, like this way. Okay, so this is why ammeter has to put inside of the water stream or put inside of the like in the current. Okay, so like this way. So ammeter can put in this way. But for voltmeter, we have said before, voltmeter is like apparatus to measure the height difference. Okay, so maybe here you have to put on the side of the lamp or on the side of the battery, because we said battery is like a pump. Here on the positive terminal is like 10-meter height, and maybe here is like 0-meter height. Okay, this is for the pump. And if we are using wire to connect with each other, and here at these places, there's also 10-meter, and here at this place is also 0-meter, okay? So here, the height doesn't change. So also, the current will just transfer through them, but here we can use the apparatus to measure, oh, here's the difference between 10-meter and 0-meter is 10-meter. And here, the difference between 10-meter and 0-meter is also 10-meter, so we can get both 10 on the voltmeter, okay? So this is how we draw the simple circuit at these places. You have to remember all of this, okay? And maybe here we have already said ammeter is using to measure the current, right? So it's just like in your the apparatus to measure how the charges walk through this, right? Maybe in 1 second you can find, or maybe in 2 seconds you will find that they're passing through 4 charges, okay? Now, so we can say that 4 charges in 2 seconds for the velocity of the water, it is like 2 charges per seconds, right? It's like this way, okay? So we're using this to represent what is ammeter's reading, okay? So here we can find, we have a definition of the electric current, right? That is the current equals to the charge per seconds. Just like you have measured the water drops, right, in the lake. Maybe for 1 second, how much of the water drops will move through the water, like this way, okay? So it's like the same meaning. So we use number of charges or the value of the charge over the time taken. So it's I equals to Q divided by time taken. Okay, so here is it. And we can say that for here, the current is the answer. So here is the A, and Q means the charge, and the value or unit of this is C. And for T is seconds, okay? So the unit A equals to column divided by seconds, okay? So this is for how we calculate the current, okay? So here we can set the charge Q equals to the current I times time taken like this way, okay? And here maybe for the readings to answer, we can set this 4 charges go through the ammeter in just 2 seconds, okay? This is how we calculate the electron flow and for the total circuit like this way, okay? So we get a unit called ampere to represent for the current, okay? This is I, it is ampere, okay? So another meaning for potential difference is just like we have said, like a height difference, right? So for here, maybe the battery's potential difference is 1.5 voltage. That means maybe here is like 0 meter, and here's like 1.5 meter as a pump. Okay, so here we can say that, oh, here's a water stream or the current, electrical current just moving through the circuit, okay, like this way. So there's a potential difference between each components, okay? So here we have another advanced meaning of the potential difference and multiple cells. Like here, for each battery, the potential difference is 1.5 voltage, okay? And you put all the batteries or all the 4 batteries in a series, you'll find that maybe here is for like in the lake, there's 0 meter, and here maybe it's 1.5 meter, and here is 3 meter, and here is maybe 4.5 meter, and here is maybe 6 meter, okay? So we have the total potential difference is like 0 meter to 6 meter, and the height difference is 6 meter, right? So it's also like here, the voltage is like 6 voltage, okay? So this is how we calculate the potential difference, okay? So like here, we can, if you're using a voltmeter on the 2 side of the battery, and we can set that the voltmeter is reading as 6 voltage, okay? So let's move into this exercise, please, and try to solve this problem, please. Okay, so I guess you have your answer, right? So for current, we said it's from positive terminal to negative terminal, right? So here, like current is like this way, right? And for electrons, we said it's a very opposite direction with the current. So like here, electrons just move from the negative terminal to positive terminal. So they are moving like this way. So we can say we are choosing B for our final answer, right? So there are 2 different ways for current moving, okay? This is our today's lesson. I hope you can fully understand about how the current will flows and what is the meaning of circuit and how we can calculate the answer, okay? Okay, so here's today's lesson. See you next time. Bye.